Hey everyone, welcome to Tech Wild. In this linear algebra for data science series, we are going to see in this video about equation of a line and how this equation of a line can be extended into a plane and a hyperplane. And we will see the equation for a plane and a hyperplane as well. First, we will see what is a line. Okay. So this is we represent in 2D. This is x1. This is x2 for simplicity. Okay, we all know this is a line, right? This is a 2D representation. In 2D they call it as line. Okay, in 3D they call it as plane. In n dimensions they name it as hyperplane. Everyone should know this. So in 2D representation, the equation of a line is y is equal to mx plus c. Okay, this is slope and this is intercept. Okay, and the general form of this equation is ax plus by plus c is equal to 0. Okay, now this general form, this is the general form. Okay, general form. This general form can be written as y is equal to minus c divided by b plus minus a divided by b into x. Okay, which is nothing but minus c divided by b minus a divided b into x. This is the form. This form is very similar to this form. Okay, now we know this is the general form, right? Now substituting x for x1 and we are substituting y for, here we represent y as x2, so we are putting x2 here. Okay, we are putting x2 plus c is equal to 0. So for simplicity, instead of a and b and c, I'm going to make it as w1 x1 w2 x2 plus w0 is equal to 0. This is the 2D representation, just nothing but the equation of line. Okay, now for extending into the 3D space. Okay, we are going to extend this particular thing for the 2D representation into 3D space. 3D, in 3D this line is called as plane. Okay, now we are going to extend the line form to 3D space, which is nothing but the, it is called as plane. Okay, how a plane will look like. Assume this is x1, x2, this is x3. Okay, a plane will look like this. This is the plane. So we saw the equation of a 2D space is ax1 b x2 plus c is equal to 0, right? This is what we saw. In 3D it is written as ax1 bx2 plus c x3 plus d is equal to 0. We have extra term. Okay, now we are, for simplicity, we are substituting, instead of a for, we are putting w1 x1, then w2 x2, w3 x3 plus w0 for the intercept term. This is one equation. This is 3D representation of a plane. Okay, now we are going to extend the same idea for ND space, which is called hyperplane in this scenario. Hyperplane. For hyperplane, same W naught, this is the intercept term which is going to be there for any case. Then W1 x1 plus W2 x2 and so on till Wn xn. We can also write this term as W0 plus summation I is equal to 1 to n Wi xi. This is the representation of ND space equal to 0. Okay. In the vector notation, how it would be represented? W0 plus Wn W2 W till Wn into x1 x2 till xn. This is 1 cross n, this is n cross 1. We have seen that. So if you multiply this, you're going to get this term. So this is nothing but the same represent. These both are equal. Okay, so these both are equal. So we can also put equal to 0. We have said previously in our previous videos, the default representation of this one is a column vector, just same as like this. So this is how typically the W vector will be mentioned at the start. So our W vector will be looking like this one. This is the default. We have said column vector is the default vector. This is column vector. Okay, so how we can represent it in a plane representation? A plane equation is nothing but W0 plus W transpose. We are taking transpose of this W transpose x equal to 0. This W is n cross 1 and this one is n cross 1. I'm sorry, it is 1 cross n. So we can identify this one with this. When you have the column of one vector is equal to the column of row of another vector, when the both are equal, then only we can do the multiplication. Okay, so coming to the 2D representation itself, since it is easy for us to visualize, assume I have a line. This is x1, this is x2, and assume we have a line like this. Okay, now we have a distance from origin to the line here. This distance is the intercept in our equation of a line. This c is nothing but this distance. Okay, we have previously written the equation of a line is W1 x1 plus W2 x2 plus W0 equal to 0. Now x2 is equal to W0 divided by W2 minus W1 divided by W2 into x1. Just this is nothing but the y is equal to c plus mx. This is just same. Okay, now C is equal to minus W naught W2. Okay. Now we will see line passing through the origin. Passing through the origin. Okay. Now, if a line passes through an origin, then my intercept will be 0. C is the intercept in our equation, mx plus c. Okay, this will be 0. So we know our 2D representation we have written as w1 x1 plus w2 x2 plus w naught. So here w naught is the intercept. We have seen that in the previous slides. So if we will be putting 0 here. So this is what we end up having. w1 x1 w2 x2 equal to 0. So by extending to 3D, in 3D we will be having x1 w1 x1 w2 x2 w3 x3 equal to 0. For ND space, you will be having w naught is 0, so you will be having summation I is equal to 1 to n wi xi equal to 0. As simple as that. So for the vector representation, we have seen that equation of a plane, which is nothing but the capital W naught plus W transpose X is equal to 0. So when you intercept, when the line passing through the origin, then your intercept is 0 here as well. This is what you end up having at the end. Okay. Assume this is a plane and W is here. W is a vector that is perpendicular to this plane. Okay. Then the xi's will be here. Okay, for any xi, for any point. This is x1, x2. For any point lies on a plane, but if your W is perpendicular to the plane, then W dot W then W dot any point xi is equal to 0 for all xi belongs to plane. Okay, so what is W dot product of xi? W transpose xi, W transpose x. We have seen from the previous videos norm of W, this formula we have seen with A and B representation. Cos theta Wx is equal to 0. So here, if 2 points are perpendicular, we have seen that when 2 points are perpendicular, then your angle is 90 degree, right? Then cos theta will be 0. So whole term will become 0. That is the reason we saw the basics of points. Now we are connecting that to the vectors in a plane itself. That's all for this video. We have came to an end of the linear algebra for data science series. In the next video, we are going to look into mathematical concept of our first machine learning algorithm with coding, which is nothing but the linear regression. I'm very excited to teach that. Please like and subscribe and press the bell icon for updates about the next videos. And any queries, please put it in the comment section so that I can answer. Happy learning. Cheers.